Good morning. Today we are going to be doing some homework corrections because I realized that we haven't done them in a while and I don't want to have to do 7 assignments or something like that for one homework correction. So we're going to go over these homework problems and many of you asked questions about Monday's assignment, so we'll pay a little bit closer attention to that one, but you need to get out all 3 of these assignments and you need to get out a red pen, or you need to get your computer out and open these up and be sure you're using red pen, but you have to, or red ink on the Google Doc, whatever you're doing. Be sure that you include the entire assignment. You don't just write the answers that you missed. You include the entire original assignment and you correct that original assignment so that I can verify that you have all the correct answers and that you aren't just writing down some random answers because you don't have your homework assignment anymore. Remember that these are worth 5% of your overall grade, so it's very important that you take this seriously. These are going to be due by the end of the period, and then tomorrow we will finish section 3, I think it's tomorrow, 3.1, and then we'll do homework corrections one more time this week, I think, and then we'll do a review before your quiz. Okay, so we're going to be starting with Tuesday, 20th of April assignment, which was 3.1 C, D, and E. Alrighty, so here is 3.1 C, D, and E problems. Number 1 says to determine the resultant given the following vector components. So the first one, A here, says that a box is being pulled upward and to the left, and your responsibility is to figure out the resultant. Well, the resultant starts at the tail of the first vector and it ends at the arrow or the head of the last vector. So this is the correct answer there for A. For B, it says Samantha walks southwestward. So this is a little bit, I didn't write this question super great. It's not the most clear, but it should be south. You should have a south pointing vector and a west pointing vector, and then your resultant should look something like that. Letter C says that Jake the dog is running and his momentum is in the southeastern direction. So the south and to the eastern direction, and your resultant would look something like that. And finally, D says that Jenny swings a bat up and to the right. So up and to the right. So your resultant looks something like that. So there we go. Those are the answers for number 1. And number 2 now says to determine the vector components given the following resultant. So this is the opposite of what we were just doing. You're given the components. No, you're given the resultants, and you have to figure out the vector components. So A says that a box is being pulled in a 125 degree direction with a force of 320 newtons. So 125 degrees is somewhere like around here, we'll say. I'm going to make my resultant red, actually. It's going to be somewhere like this, right? Because 90 degrees plus, yeah, somewhere around there. And it's this angle here, because it specifically says, remember that all angles are given in the counterclockwise of east convention unless otherwise stated. So this angle is 125 degrees, counterclockwise of east, and the force is 320 newtons. All right, so what you need to do now is figure out the result, or the vector components here. So it doesn't matter if you figure out the components here this way and this way, or if you do this way and this way. It doesn't matter which way you drew your triangle. I am going to draw mine this way and this way. So these are my 2 vector components that I'm trying to figure out. My right angle is right here. Ira says hello. And I can figure out this, let's zoom in here. I can figure out this angle right here. We're going to call this angle theta. And I know that theta is going to be 180 degrees 180 minus 125 degrees, because that's how much I have over here. And this whole angle right here, remember, is 180 degrees. So 180 minus 25 minus 125 is 55. So theta here is 55 degrees. Okay. So now we may begin our problem solving, because we need to find the lengths of both of the vectors. In order to completely find the vector components, we have to do some math and solve for the lengths of the vertical and horizontal vector. So we're going to call this A, going to call this B, and we know C. So what we're going to do first is we're going to do a little trigonometric method. So I'm going to use sine of theta. Whoops, I don't need to write the E. I always do that. Sine of theta equals the opposite, which would be A, over the hypotenuse, which would be 320 newtons. So I actually know theta here, so I don't need to write theta. I need to write 55. All right, so I'm going to rearrange this by multiplying both sides by 320 newtons. And then I'm going to have sine of 55 times 320 newtons equals length, the side A. And when I plug that into my calculator, I find that A is equal to 262 newtons. So we can erase A here and write 262 newtons. All right, now all that's left is B. I'm going to use cosine of theta, which is 55, and that is equal to the adjacent, which is B in this case, over the hypotenuse, which is 320 newtons. When I rearrange, I get this. When I plug that into my calculator, I find that B is equal to 184 newtons. All right, so there we go. There is my 184 newtons. There is my answer for letter A. Now for 2B, we have Emily, who is running who runs 8.5 kilometers in a 305 counterclockwise of east direction. So that's around here, we'll say. So we have 8.5, and we have an angle of 305 degrees. All right, so what we're going to do now is we're going to find our vector components. Here's our right angle. We know that this little angle, theta here, the remainder of this little guy right here, is going to be 360 minus 305, which conveniently and weirdly enough, again, is 55 degrees. All right, so now we're going to solve. We have A and B here. We're going to do the exact same thing we just did. We're going to use sine of 55, sine of theta. We're going to do opposite, which would be B, equals opposite over hypotenuse, which is 8.5. When I rearrange and plug that in, I find that B is equal to 7.0 equals B. All right, so B here, B is 7.0. Now to find A, we are going to do cosine of 55 is equal to the adjacent divided by the hypotenuse, which is 8.5. So when I rearrange all of that, I get that A is equal to 4.9 kilometers. So there is 4.9, my answer and my diagram for 2B. Moving on to 2C now. We have a ball that is rolling at a 49 degree angle for 30 meters until it comes to rest. So we have 49 degrees is about right there. And our angle here That's 49 degrees. And we're going to find our two vectors, which are here and here. Going to do the exact same thing again. There we go. So there is the solution. You can pause it and take a look at that and make sure you have the right answer. And moving on to 2D, I'm going to do the same thing. Here is the answer. All right, so there we go. There is our answer for the last one. You can pause that again. What I did here is I did the exact same thing, drew out my diagram. I have 10 degrees counterclockwise of east, so I have a very tiny or very, very tiny angle here, which means A is very small. So yeah, this is how I got that. Did the exact same thing, and I got 0.6 meters per second for the vertical vector, and 3.2 meters per second for the horizontal one. Okay, so that is it for 3.1 CDE. Now we're going, We're going to move on to 3.1F Part 1 questions. So, number 1 says that Craig the kitten is pulling and pushing a box. He pushes the box southward with 10 newtons of force. Then he turns and pushes the box eastward with 5.75 newtons of force. Finally, Craig pushes the box in the southern direction with 3.35 newtons of force. So, first thing we're going to do before we even... Well, it says that right here, actually, for number 1. Draw a vector diagram. So I won't give you this on a quiz. I'm not going to break it down that simply for you. But as soon as you read a question like this, your very first thought should be, okay, I have to draw a picture because, it's just impossible to see what's going on without drawing a picture. So let's see. First, we have southward with 10 newtons of force. So we're going to start right here. We're going to go southward, and this is going to be 10 newtons of force. And then he turns and pushes the box eastward with 5.75 newtons. So we're going to turn and go eastward with 5.75 newtons. And then finally, he's going to push the box in a southern direction again with 3.35 newtons of force. So there's the letter A. Draw the vector, the vector diagram of the box's path. Then we're going to redraw the box's path so you can determine the magnitude and direction of... Oh, this should be frog. I obviously was... Yeah, you figured it out. We can see the box's overall direction of its overall force. So remember, when we're doing... These are all perpendicular. They're either horizontal or vertical lines. So what we can do is we can move them around so that all of the vertical lines are together. So we still have this 10. Oops. You know what we could do also? I'm going to do this just so we can start and finish right there. So that's what our resultant's going to look like. Just FYI. Okay, so we're going to do our 10 Newton line. Now we're going to take this horizontal or this vertical line and we're going to scooch it over to here. So it's right next to the other vertical line, 3.35 newtons. Then we're going to go over this way, 5.75 newtons. Now when we draw our resultant, we see it's the exact same resultant, right? Okay, so we've redrawn this so that we can determine the magnitude and direction. What we've done is we've redrawn this so that we have a right triangle. We have perpendicular vectors so that we can solve for our magnitude and direction of our resultant. So let's add these two together. These two, we're going to add these two together. So we're going to have one long vector length here of 13.35. 10 plus 3.35 is 13.35 newtons. Alrighty, now we are ready to do all of the stuff. So this is, remember, we're going to use Pythagorean's theorem. We have A, B, and C. We're going to do A squared plus B squared equals c squared. Plug everything in. I get 13.35 squared plus 5.75 squared equals c squared. And we get 211. 211 equals c squared. Take the square root of both sides. And we get 14.5 newtons. So the magnitude of our resultant here, the overall magnitude of the force that Craig uses, is 14.5 newtons. Now what we need to do is determine changing my colors, theta here. Well, not necessarily theta. We're going to determine this whole angle, but we are going to start by determining theta. All right, so let me erase all this. In order to solve for theta, we're going to use sine function. Sine of theta equals the opposite over the hypotenuse. So we get 5.75 newtons divided by 14.5 newtons. When we plug that into our calculator, we see that the sine of theta is 0.40. When we take the inverse sine of both sides, we get that theta equals 24 degrees. Okay, so theta is 24 degrees here. So this is 24 degrees inside, 24 degrees. So now what we need to do is, if we imagine this as an axis here, we need to add 270 degrees, right? Because we add 90, 90, and 90, that gives us 270. So we get that this resultant, so the correct answer here is, we say the resultant has the overall magnitude of force is 14.5 newtons, and the overall direction of the force is, you could say, 294 degrees counterclockwise of east, right? Because 24 plus 270 equals 294 degrees. Or if you don't want to do that, you could say 24 degrees. This would be east of south. All right. So either of those answers is correct, unless I specified, which I don't think I did. I did not. So either one of these answers is correct. You can use 294 or 24 degrees east of south. You just have to specify. You can't just say 294. You can't just say 24. All right. So that's number one. Let's do number two real quick. All right. Number two says that Jack the Frog hops 6.33 meters to the west. So let's just draw it while we're reading. He's going to hop 6.33, and he's going to go, 6.33 meters to the west. Then he turns and hops 4.10 meters in the southward direction to a pond where he stops and has a drink. Jack then quickly hops 1.15 meters northward to eat a delicious fly. So I'm going to draw this one in red so we can see it. 1.15 meters. And finally, he hops 3.0 meters westward before turning around. Wow, two more things. Okay, he's going to go westward again. I'm going to draw all of these in a different color real quick. Well, there we go. Okay, so we have the start. This is a disaster. So to start, we have 6.3 meters to the west. Then he turns and hops 4.10 meters in red here, in the southern direction or southward direction. In pond where he stops and has a drink. He then quickly hops 1.5 meters back northward. So that's the green one. 1.15 meters to eat a fly. He then goes 3 meters west in black here before turning around and hopping 10.86 meters in the eastward direction. So this is what letter A looks like. Kind of a disaster, but that is what it should look like. If you want to draw, let's draw our vector here in another different color, or not our vector, but our resultant. Our resultant is going to be, remember, it is at the start, the start of the very first vector, and it goes to the end, or the head of the very last vector. So there's our resultant, all right? Okay, so this is what we're working with. Now we're going to redraw Jack's path so that we can determine the magnitude and the direction of his overall displacement. So to do this, we are going to combine all of the vertical and all of the horizontal vectors. So here's B. First, I guess since we have only these two vertical ones, let's put them together to start. So we have this way 4.10, and then we have going back up this way, so we're going to have to subtract these, 1.15. All right, so another way that we can do this, when we have vectors going in the opposite direction, what we can do is we have 4.10, we can subtract minus 1.15 in order to find the total distance of this, right? So we erase this part. All right, so now let's determine what is the total distance left. So this vector has a total distance of 2.95 meters. Okay, so we're good for all of our vertical components. Now let's look at this messy. We only have 1, 2, 3, right? We have the blue one, we have the black one, and then we have the pink one. So let's do our blue one first. Let's do our pink one first, actually. That's going to maybe be easier. Let's do the longest one first. So we have to start where we finished. So we're going to go this way, 10.86 meters. All right, now we need to do subtract, I guess you could say, 6.333, and then also subtract 3.0. All right, so now we get a resultant that will be from the start to the, there we go. It's the same, right? It's going to be a similar, or it's the exact same resultant. It doesn't matter how we add all of these together. So let's rearrange this though, so that we know our actual length here that we're left with for our horizontal component. All right, so we have 10.86, and we're going to subtract 6.33 and 3. So we have 10.86 minus 6.33 minus 3.00. When we put all that together, we have a distance here of, let's make that smaller, of 1.53 equals 1.53, which is the distance. We erase all of this. This is the distance of this one right here, 1.53 meters. All right, so now we have, what did B want us to do? It just wanted us to redraw. Okay, so there we go. We have a 90-degree triangle. We're good to go. So now we can work on basically just doing what we were doing before and solving for our magnitude and our direction of our resultant. So this is going to be theta here, right? And we can use this, we're not going to use that yet. Okay, so we are going to look at A, B, and C. We're going to use Pythagorean's theorem. A squared plus B squared equals C squared, which is this, and we plug our values in for A and B, and we put that into the calculator. We get 11 equals C squared. When we take the square root of both sides, we get that C equals 3.3. All right, so our magnitude of our resultant here is 3.3. 3.3. Now that we know that, we can use the trigonometric method in order to solve for theta. So we're going to use the sine function. We're going to use opposite, which is 1.53, divided by hypotenuse, which is 3.3. When I plug that in, I get that the sine of theta is 0.46. When I take the inverse sine of both sides, I get that theta is 27 degrees. Okay, so the way that the correct answer here, or the way that I'm going to write my answer, is that the overall displacement of the frog is 3.3 meters in you could either say a 27 degree, this would be east of south direction, or you can say a 297 degree counterclockwise of east direction. All right, so either one of those would be correct. And the way that I got 297 is because we have an axis here, and this right here is 270, right? And then if I add 27 to that, I get 297, and that would be counterclockwise of east. Woof. Okay, so that's it for 3.1F Part 1 questions. Now we're going to go through the questions that you did on, I believe it was Monday, 3.1F Part 2. So, to start, we have Mahfoud is dribbling up the field during a soccer match. He runs northward for 3.1 meters. So he's going to run northward for 3.1 meters. Then he turns sharply and sidesteps in a 60-degree counterclockwise of east direction for 1.8 meters. So now he's going to go, I'm going to move this guy down. He's going to go in a kind of 60-degree, that's a little more like 45, maybe a little sharper. 60 degrees for 1.8 meters. 1.8 meters. Counter to the east for 1.8. He runs northward again for 2.2 meters. Like this. And finally, he shuffles in the eastward direction before shooting and scoring a goal. Okay, so it doesn't say anything, so I'm just going to stick with this. I must have forgotten to give you... Yep, I forgot to give you a value for that. So no one asked me about that, so I assume you just started and stopped with the ones that I gave you. So we start here, and we're going to go up to here. That should be a straight line, but it's not. Try again. There we go. That's our resultant. Okay, so let's figure out what we can do here. So obviously the first thing, I'll redraw the resultant later, but obviously the first thing that we're going to need to do is to transform any of the nasty vectors, angled vectors that we have. So this one in the middle, this 1.8, this is a nasty vector, so we're going to have to transform that. So we have two components to this vector. We have an eastward component and a northward component. So we're going to call this, just randomly assigning this as A, B, and C here. So this was our A, this is our B, and this is our C. So I'm going to just randomly call this B, Y, and B, X. Now I'm going to solve for those two. And I'm going to solve for those two like this. This is my theta. All right, so I'm just going to use the trigonometric method because I actually know theta, right? This isn't actually, this isn't actually theta. This is 60. This is a 60-degree angle that was given to you in the problem. So we know theta, so we can use the trigonometric method. So what I'm going to do is I'm going to say sine of theta, which theta is actually not theta, it's 60. Sine of 60 equals the opposite, which is by, over the hypotenuse, which is 1.8. If I rearrange that, I get sine 60 times 1.8 equals by. Then I plug that into the calculator, and I find that by equals 1.6. All right, so there I already have my by component here. We have 1.6 meters. Now we will solve for bx, and I'll do that by using cosine of 60, cosine of theta, equals the adjacent, which is bx, over the hypotenuse, which is 1.8. Rearrange, I get cosine 60 times 1.8 equals bx. When I plug that in, I find that bx equals 0.90. All right, so now I have 0.90. All right, so now I've got these two, I've gotten rid of this nasty angled vector, and I've broken it down into these two more usable vectors. So the next step here is to remember we're going to add all of our horizontal and all of our vertical components. Then we can solve for the overall displacement and the magnitude and the direction. All right, so we're going to put all of our vertical and all of our horizontal together. So when we do that, we have this 3.1, and then this purple one, which is 1.6, then this green one, which is 2.2, and we're going to take our other purple guy, and it is over 0.90, like that. All right, so our resultant, remember, is it looks the exact same in both situations. We're starting down here and we're going way up here, starting down here and going way up here. They're the exact same resultant. We just rearranged our vectors. So what we need to do now is add 2.2 plus 1.6 plus 3.1 in order to determine the length of this whole vertical side. So when I do that, I find that this side is going to be equal to 6.9 meters. And now I have my right triangle. I can do all of the things in order to solve for my resultant. I can find, I'm going to figure out theta there. First, I'm going to actually use the Pythagorean theorem in order to solve for my magnitude, because I have A, B, and C. So Pythagorean's theorem, like this, I plug my values in, and I plug that into the calculator, and I find 48 equals c squared. Take the square root of each side, and I get that c equals 6.9. All right, so erase that. We get c equal to 6.9 meters. All right, now to determine the angle that this this vector is at, we are going to do sine of theta equals the opposite, 0.90, over the hypotenuse, 6.9. When I do that in the calculator, I get that the sine of theta is equal to 0.13, inverse sine of both sides, and the theta here is equal to 7.5 degrees. All right, so a correct answer would be that the overall displacement is 6.9 meters in a 7.5 degree, what would that be, east of north direction. Or if I asked you, I don't think I asked you for counterclockwise of east, but if I did, this would be an 82.5 counterclockwise of east direction. And I got that 82.5 by subtracting 7.5 from 90 degrees, because this whole angle here, right, is 90 degrees. So that's how I got that. Either one of those answers is correct, but you have to specify. All right, now finally number 2, this big messy number 2 that everybody was complaining about. I love this problem. Okay, so Yustra and her friends are on a hike up the treacherous Kilimanjaro. They make the following movements during their hike. So first we have movement A, which is 1.8 kilometers in the 140 degree counterclockwise of east direction. So that's something like here. I shouldn't draw that over there. I'll do it, scooch it over here. All right, we're going to call this A. Then movement B is 3.65 kilometers in the 252 degree counterclockwise of east direction. That's somewhere, we're going to do this one in red. That's somewhere 200 and, what is it, 52? All right, that's somewhere like, kind of like this. And it's a longer one because it has a greater magnitude here. And that is 3.65 kilometers. And this is vector B. And finally, it says that the last movement, movement C, is 3.11 kilometers in a 322 counterclockwise of east direction, which is something kind of like this. All right, so this is 3.11 kilometers, and this is vector C. So our overall resultant is going to be something like this, right? All right, but I'm not going to draw that for right now. Okay, so what do we have to do? First, we have to resolve every single one of these vectors into their vertical and horizontal components. So I'm going to do this in a thicker pen here. So we need this component and this component. We have to find each one of these. So we need AX, we need AY. Then we're going to need to solve for this component and this component, which is by and bx. Then finally, we're going to need to solve for this component and move this guy down here. Up, how about that component and this component, which is CY and CX. All right, so we're going to have to solve a lot of different stuff here, okay? So let's start with A. We're going to find AY and AX. All right, so we know, what angle do we know here? We knew that this was in the 640 degrees. So 140 degrees counterclockwise of east. This was such a nice problem. Oh, it's so beautiful. Which means that theta is 40 degrees. This angle is 40 because 180 minus 140 is 40. So we have a 40 degree angle. We have a 40 degree angle. Beep. Okay. Now we can use the trigonometric method in order to solve for some of these two components. So we're going to use sine of 40 is equal to the opposite, which is AY, over the hypotenuse, 1.8. When I rearrange all of that, I get that. And then when I plug it into the calculator, I find that Y is equal to 1.2 kilometers equals AY. All right, so AY, I'm going to erase this part here. So we get 1.2 kilometers. Now to solve for AX, we're going to do cosine of 40 is equal to the adjacent, which is AX, divided by hypotenuse, which is 1.8. When I rearrange, I get this, and when I plug in, I get that. So here I have transformed my wonky, not beautiful vector into two usable vectors, a horizontal and a vertical component. So I'm going to just go ahead. I won't erase it, but will I? No, I won't erase it yet. Okay. So now we can solve for our red one here for B. We're going to do the exact same thing that we did. First we have to verify what is theta, what theta is here. We have this angle right there, but our theta, we don't know. But we can figure it out because B is at a 252 counterclockwise of east direction. So this is 252 degrees. So in order to solve for theta, we need to subtract 252 from 270. And when we do that, we get 18 degrees. 18 degrees. So theta is 18 degrees there inside the triangle. Now we have our right triangle there. Okay, so we can solve for Bx and By using the exact same method that we just did with sine and cosine. So sine of 18 is going to equal the opposite, Bx, over the hypotenuse, which is 3.65. I get this. And when I plug that into the calculator, I find that Bx is equal to 1.1. All right, so we know our Bx here is 1.1 kilometers. Now to solve for By, we're going to use cosine and do the exact same thing. Cosine of 18 degrees equals By, which is the adjacent, over hypotenuse, 3.65. Rearrange, and then plug into the calculator, and I get 3.5 is Bx. Excuse me, By. 3.5 kilometers. Okay. All right, so now we've resolved B into its horizontal and vertical components. Now we can do the same thing finally for C here. So we know we have a 90 degree angle here. We know that this angle was 322. So if we take 360 degrees minus 322, wait. Yeah, that's the only way to do this. No, that's not the only way to do this. It's the more complicated way to do this. Sorry. Let's do it the most simple way. So we have this 322 degree angle, and we're going to subtract 270, right? Because up to here is 270 degrees, and then whatever is left is the what's left. So 322 minus 270 gives us a 52 degree angle there. So our theta is 52 degrees. Theta is 52 degrees. Okay, now that we know that, we can solve for cx and cy using sine and cosine. So the sine of 52 is equal to the opposite, which is cx over hypotenuse, which is 3.11. Multiply both sides by 3.11, and I get sine of 52 times 3.11 equals cx. And I plug that into the calculator. I get 2.5 equals cx. Where's the 2.5 kilometers? And now I can use cosine to solve for cy. So cosine of 52 equals adjacent, which is cy, divided by hypotenuse. Rearrange. Cosine of 52 times 3.11 equals cy. Plug that into my calculator, and I have 1.9 is cy. 1.9. Okay, guys, we are literally almost done. All right, so now that we've done all of this, we have resolved we have transformed all of our angled vectors. This vector here, this angled weird vector, this angled weird vector, and this angled weird vector. We've transformed all of them into horizontal and vertical components. So what we can do now is we can, I'm not going to erase this, but we can take the, how do I highlight these here? Yeah, I guess I am going to have to, we're going to take all of the vertical components and all of the horizontal components, okay? And we're going to make a right triangle out of those. So let's just start with the horizontal. So we're going to take this blue, this one here, this one, and this one. And we're going to make it one side of our triangle. So I have 1.4 going this way. So I have 1.4 in this direction. Then I have in red, I have an additional 1.1. Then my green is in the exact opposite direction in 2.5. 2.5. Oh my gosh, I did not do that on purpose, but I love that my brain made it exactly correct, like exactly back to 0. That is amazing. Oh, wow. Okay, cool. All right, now we're going to take all of our vertical components. So we're going to take 1.2, so that's 1.2 in the upward direction. 1.2 kilometers. Then we go down, 3.5. Down, 3.5. Then we take, sorry, that was this long one right here. Sorry, I'm getting out of control with the circles. And then now we're going to take this last vertical component, which is 1.9. Okay, so let's see. We started up here, right here. This was our starting point, right? And our ending point is this straight line down here, right? So crazy. There is no, this is so beautiful. There's no angle. Our resultant is just going to be this magnitude. Okay? Man, if you got this... I didn't mean to make this exactly the same. I meant to make it... I thought I made it one less. I thought I made it 2.4, so that it was just going to be like really super skinny little angle there. But anyway, so doesn't matter. You could still solve it. It's just a brain twister. If you got this right, you are wow. Serious points. I would probably give some extra credit if you got this right. If you didn't, it's still a valuable question because this is just like a big brain stretcher. So this was our starting point, right? And our resultant is actually just along one side of our triangle, right? Because there's no angle. So we made our right triangle, but it actually, because these are the same, because they cancel each other out, we have 2.5 going in the leftward direction, right? From here to here, this was 2.5. And then we had 2.5, the green one there. This green one was also 2.5. So our starting, or our this whole arm of the triangle is basically, it doesn't count. I mean, it gets canceled. So our starting point and our ending point are on the same, they're in the same line. They're actually just on the y-axis, or on the pointing south, you could say. So we're not going to, we can still give an angle here, but let's look at our magnitude first. Our magnitude is going to be 3.5 plus 1.9, because this one was in the opposite direction, right? So we cancel that one out. We don't count it. So our distance here is 5.4 kilometers. No. That's not right. Oops. Here we go. All right. So we are not... where's my pen here? Okay. So we started up here at the top. I've drawn lines over lines, so I'm confusing everybody. Sorry. Let's redraw this line. Remember we started with 1.2 kilometers up, right? Then we went 3.5 kilometers down and an additional 1.9 kilometers down, right? So we actually can't add 3.5 because I thought that this line was 3.5, but it's actually not. So what we need to do is add 3.5 plus 1.9, 3.5 plus 1.9, because those two vectors are in the same direction, right? This red one, and this green one, they're in the same direction. So we get 5.4 going down, but we have to subtract this 1.2 up here because it's going in the opposite direction. So when I do that, I get this arm is 4.2 kilometers, in fact. Whew. Okay, so our magnitude, the overall magnitude of our displacement is 4.2 kilometers, and it's in the, you can either say southern direction, or you could have said the 270 degrees counterclockwise of east direction, right? Because 90, we have, this is way too complicated here to draw this over everything else. Let me make my pen thicker. Maybe that will look better. So this is, from here to here, is 270 degrees, right? Because each quadrant is 90 degrees. So either way you said it would be correct. Oof, that was a nice problem. That was a tricky one. Didn't mean to make it that tricky, but if you got it right, I'll give you some bonus points because that was a very nice question. All right, so that is it for the homework corrections for sections C through F. Like I said, we'll have one more set of homework corrections for section 3.1, and then we'll do review and do some more practice problems and then go over those practice problems. And your quiz will be next week, we'll finish section 3.1 either tomorrow or on Friday. So whatever day we finish, I'll let you know what day the quiz is. Okay, so that is it. You need to hand in your homework corrections before the end of this period. Please let me know if you have any questions. And that is it. Have a good rest of your day.